Thank you all for coming. I've been doing a lot of work in different areas, but one of the things that's been in common is actually using Faire. And the make movement has been pretty revolutionary. I mean, a lot of people have ideas, they want to do crazy things, they get stuff done. And it is pretty amazing. One of the fascinations that I had was with jetpacks. And like 15 years ago, I brought a prototype of a jetpack. And that exposure, and that actually led to getting involved with a company called Go Fast Sports. Also building prototypes of things. So this was actually a little flyable jetpack that just used compressed air, but importantly, it emulated the controls of a jetpack. And this is someone at Tech Shop actually trying it. So they were told, you know, which one would actually cause thrust to go up and down, and then which one would actually cause pitch motion to cause turning. So there was this type of simulation. We also built software simulators, and this was in lieu of getting to the point of building an actual jetpack. What happened was eventually I met a company that was producing jetpacks. And they won on things. There was a show called Big Idea with Donnie Deutsch. I don't know if anyone ever heard that or know who Donnie Deutsch is, but and I'll just kind of skip through this, but you know, they were interviewing us all, talking about, you know, making this jetpack dream come true. Did a flight at the studio, and then at the end, the software simulator, Donnie Deutsch actually attempted to fly it. So this was his green screen version of that. And again, this is kind of like just this DNA of getting to ideas rapidly and actually making them happen. This was at Maker Faire. This is Mike Rowe. You probably know Mike Rowe of Dirty Jobs. And this was, again, the same simulator. And there, you know, we are going through, you know, how to use that. But more importantly, it led to, oops, let me go back one. It led to actually working with this company, Go Fast Sports. And there was a crazy flight, and again, this is all
I'm actually here with Eric Scott, a 45-year-old from Denver. He is about to put on his jetpack.
I'll mute it a little bit, but you know, they're interviewing him, and he's going to fly across this canyon. There I am. You know, we just set up, we calibrated, we did all the things. There's the owner of the company, and he actually goes through, and it's a very hazardous flight, and everybody's, you know, doubting if he can make this flight. But in the end, and again, just kind of skipping through, he makes the flight. And what was interesting about the flight, and even if you watch this flight, I mean, it's pretty cool. He flies across and he lands. And when we did the simulation, originally he was going to start where he's landing. And if you see, it's actually a 30-foot drop. And using the simulator, when we did rehearsals of this flight, you know, going from that area where he landed, he couldn't have made it because he would have run out of fuel trying to get the elevation. So, and, let's see. So this was actually using the flight simulator, and this is the flight going the right way. So what was interesting is Microsoft's flight simulator had high enough resolution of the actual terrain and the bridge that we could use that in the simulation. So that was really cool stuff. And again, it's like, you know, meeting people through the Make community, you know, really, you know, fostered the development and the integration of using simulators with something that before was more just by feeling. Also for the genetics of, you know, how we got to where we are right now doing space stuff. You know, I and Alex both have worked on a lot of toys, and probably the most, and even today, it's one of the more sophisticated toys. There was a robot dog called iCybe, and this was actually the production factory, and I've spent months in China setting this factory up with a company called Silverlit. This is actually, you know, building the product. And so we did this to ISO standards, and they had not done that before. So a high degree of testing, a high degree of using test fixtures to test subassemblies before assembly. Because I told them that basically when they build this product, they want to have 100% tested it 4 times before it was completely finished. And they were so proud of it that, you know, they did make this movie about, you know, the assembly process. So just kind of fascinating to see. And again, that we're talking about, you know, the year 2002 when we were doing this. So the level of degree of precision and the testing. So here's like a typical test fixture for the legs. So they can 100% screen the legs and sort them out to see if they need rework or not. And again, a lot of the ideas, you know, and the funniest idea too, from a maker standpoint is, you know, I told the boss, I said, I love all your workers, but there's one problem. They only have 2 hands. And they need fixtures. So the use of fixtures, like all of these that are sitting on fixtures, is critical to having high production yields. Because before, the assembly person had to chase this assembly around with screws, and it was very difficult to build. So this got the production yield. We had like a 98% production yield, which for a complex product like this. And here's like a test fixture to actually test if the legs return to 0. Very simple fixture, but it would, you know, make sure that the robot was doing the right thing. And even when they would do these initial walks and all these other things. So this is, again, bringing, you know, make mentality to a lot of different processes. So from, you know, doing these sorts of things, I actually, you know, with the jetpack background, I was always fascinated with finding jetpacks, and I actually found one of these jetpacks that was designed for the Gemini mission. So these are the background pictures. So we finally restored it. There used to be a show called American Restoration. I don't know if any of you remember it, but at American Restoration, we did restore this jetpack, and we also built a training version. And this is meeting with Gene Cernan and Buzz Aldrin, and they were really thrilled, and they signed it. They both, there's actually signatures on there, and Gene Cernan on the inside of the panel wrote the spacewalk from hell because he had a particular problem on that spacewalk and almost died on that spacewalk. So he was very happy. Also, there's a children's center that had a Gemini capsule that was actually missing a control panel. Their control panel was damaged, so we restored and built that panel. Again, to inspire kids. So, you know, it's kind of that maker community, maker experience. So those experiences led to meeting people from NASA at Maker Faire. NASA used to have booths at Maker Faire, and it's a shame that I didn't see them here. So they actually began to utilize me as a consultant, so I was really proud, and I took this picture. So this is at NASA Ames. This is the old Commandant's building. And at NASA Ames, in that Commandant building, I actually had this little corner set up, and this was actually my workspace. So there's actually a 3D printer on the left-hand side, and my desk with a little laptop, and then these are all 3D objects that I printed. And, you know, it wound up being thousands of parts for hundreds of projects that wound up being on a dozen things that actually flew into space. So again, and this was using an early printer. I mean, we're talking, this is like a 2012 picture. So, you know, really leveraging that. The other thing is that Cornell had developed a thing called a chipsat. Now this particular chipsat is 30 millimeters on a side. And I was, you know, one of the toy projects that I had worked on was a thing called hit clips. And I don't know if anybody's ever seen hit clips before, but hit clips Actually, if you can move those gloves and then put this here. So this little chip, that board, we put it inside of that housing. And that housing is for a music player. And so, we did sell quite a few of these, but they're very robust, very reliable. But the idea of how to build these chips and build them reliably and at volume. So how to build those, how to mass produce those, and how to make them reliable. NASA got really excited about that because ultimately what it winds up being, let's see, yeah. So this is a femtosat, the more of a current version that we're currently using. So this is 50 by 50 millimeters on a side. It's 2 millimeters thick. It weighs 1.8 grams. And to give you some idea, 1.8 grams is a little less than what a penny weighs. So, the weight is important because, what we eventually do with this is pretty exciting stuff. So also these femtosats have to be carried into space and deployed. So this was an early prototype showing how to deploy these out of a satellite. And it's kind of funny, like SpaceX now, when they do their Starlink communication system, actually do almost a similar thing. And this is a final version of the hardware to deploy those. And this is another view of the femtosat. So we did actually bring it to Maker Faire about 10 years ago, and we won a blue ribbon showing, that the practicality of it, but also Zach in the middle, and then on the left-hand side is Matt Reyes. So both of these guys at NASA were pretty fundamental in this project, and their vision of bringing these things to life and bringing them to the maker community. So on the original KickSat-1, you could actually buy a femtosat of your own and program it and have it deployed. Also, in 2013 at Queens, I'll just run this. NASA has issued a grand challenge for asteroids. What that entails is the public coming up with ideas for what we can do to mitigate asteroids, study asteroids, and exploit asteroids. Maker Faire has an incredible community that's capable of coming up with any number of ideas and technologies that could be applied to this grand challenge. One of the things that we really emphasize is the use of new technologies. This is an example of 3D printing. We actually offer these models online for free for anyone to print out of missions that want to check out asteroids. This is Spitzer, and this is one of the asteroids that it discovered. Why everyone should be interested in asteroids is every day there's 2 tons of debris falling on the Earth. Some of them are as small as a pebble, and if they hit you in the head, it's a bad day for you. Some of them are as large as Manhattan Island. Those only happen every 65 million years, thankfully, but when they hit the Earth, it's a bad 4 years for Earth. There's no sunlight on Earth for 4 years. The larger, most threatening asteroids have been categorized, but it's the smaller ones that appear out of nowhere that we're really concerned about. I think that everyone should check out nasa.gov, NASA TV, and you can constantly see new announcements and new challenges that will really just blow your mind. And the reason that we were interested in that with the femtosats is the femtosats do have a magnetometer on it, and when in orbit, they can actually detect asteroids out to 200,000 kilometers. So they can give that extra warning. And the asteroid that was shown in there was called Chelyabinsk, and that actually hit Russia. And when it hit Russia, it fortunately blew up in the atmosphere. It was superheated, it blew up in the atmosphere. But the shock wave was so intense that it shattered tens of thousands of windows, and there were a lot of people that went to the ER with cuts. It also happens that Chelyabinsk is about the size of San Jose in terms of population, and it's the center where they would build nuclear weapons. So some people were even saying that they didn't know. I mean, nobody saw that asteroid coming, and they didn't know if that was a nuclear strike or not. So knowing, even if you can't do anything about it now, just knowing what it is really important for geopolitical stability. And this was a demo of an asteroid detector. So there's actually the asteroid, and you see on the screen the graphic, and there's a little chipsat, and it's actually tracking the magnetic debris or the magnetic materials within that asteroid. So it can be used for that type of tracking. And this was the Maker Faire in New York. And it also turned into a TV show. There's a TV show called Man vs. Universe Episode 2, How to Kill an Asteroid. And you can see that, I'm actually holding one that we saw. We were also looking at deploying these. That's the other thing that's interesting. In space, there's always someone trying a new launch platform. So there was a company called X-Corps who was trying to build a space plane. And the idea is that the space plane could actually be a single stage to above Kármán line flight and then glide back down so it could carry payloads. And I'll skip the movie. This was at their booth at the AGU in San Francisco. And this is Matt Reyes and myself doing a presentation on deploying the chipsats. So again, there was a lot of initial interest with that, but then the secondary feature or benefit of using these was you could actually put these on sails. So there's a concept of light sails. So this is actually using the pressure of light to propel things to planets or even stars. So let's see if I can find that.
Cornell's Alpha CubeSat is a light sail carrying one-unit cube-shaped satellite and a stepping stone to our nearest star system. Its technological innovations paved the way for future light sails to reach 1/5 the speed of light, 400 times faster than any current spacecraft.
Light sails, as the name suggests, are a lot like boat sails. But instead of being pushed by wind, light sails are pushed by the actual photons that strike them. JAXA's Icaros in 2010 made this a reality, and the Planetary Society's Light Sail 2 demonstrated sailing with sunlight, or solar sailing, while in low Earth orbit.
Solar sailing can propel light sails toward other planets, but if we want to get to Alpha Centauri, we're going to need something stronger, like laser power, and a lot more experimenting first. One of Alpha's goals is to help test these new technologies.
Alpha CubeSat's light sail design is different from its predecessors. It's a lot smaller, first of all, but more importantly, Alpha's sail has a low mass per area. The lower this mass per area, the faster we can accelerate the sail, and the shorter our travel time. Alpha has a pretty similar ratio to previous sails, making it just as efficient for a lower cost.
Alpha's palm-sized computer.
So I'll cut that short. But the sail program has been very critical to a lot of development. So one of the things that we've been looking at is, this is one of the units, and this is going to be used in an upcoming mission. So we have inside here a sail, and if you can hold that and just point it away from you. And let's see. So it's that simple, and the sail is very much like a kite. It's very lightweight. Again, the whole sail and would weigh 80 grams. So that's as much as a Hot Wheels car. And then these are the Femto satellites that we looked at earlier. So having that, and that, also having a way to, physically, and one thing I left out is normally we would have nitinol wire in here, which actually straightens the sail out completely. For these prototype samples, and to make it easy to fold, we leave it out. But this folds up. It's kind of like folding an old map. It has a origami fold to it, and then it can be, go ahead and put it in. So it's easy to even reload these. So developing these to be able to do other missions to planets and even to stars. So the other thing has been is to develop ways of assembling these satellites. So if you want to take this. So Alex has done a lot of work on the circuit design and circuit board, but this is the, actually we'll build it up. Go ahead, set it down there, flip it over, yeah. So this would be the circuit board. This particular one, to stabilize it, we're using a hard disk drive. So we're using a hard disk drive as a wheel. That's up, the LED's up. Okay. So the hard drive will slide in here. This would actually be wired up, so these assemblies would be a lot closer together. So then that snaps together. And again, the idea is that typically these assemblies had dozens, if not hundreds, of screws. So to actually come up with a way to build this with just your fingers. And the nice thing about that is that you can, build these assemblies, relatively quickly. You can even build them in zero gravity. So, that's an assembly now. The upper assembly, similarly, this would have a connector, so we want to make sure that the connector is oriented in the right way. Connector goes in here. And these are components that, again, a lot of makers have probably seen before in PCs and other things. Batteries would go in here, and this is a lid for the compartment. This is for the actuator. Micro switches. Let's do this. Micro switch here. And then the housing goes like this. So again, all snap fit. So again, to build these assemblies up is pretty quick. And then a door, so this is a deployer door that holds the sail in. And again, it's held in with a silicon washer. So, before these assemblies would have taken dozens and dozens of screws, and one of the problems is that when you do the vibration testing, they come out. So this is to actually eliminate a lot of those nasty problems that you would normally get. So that silicon washer then retains that rod to hold that assembly together. So that's building a whole satellite in just that much time. And and again, one of the things, I'm wearing a shirt. This is for the Alpha project, but it says summer of 2016. So we actually started in the 2016. We had 10 students for 10 weeks and $10,000. And that's now turned into hundreds of students and hundreds of thousands of dollars. So how do we, get that down? And again, using the maker mantra, using 3D printing, using all of these design techniques that we use as makers every day is important.
That's fantastic. Thank you, Andrew. I just, we are at time. If people want to find out more information about you and about all of your amazing work, where can they do that?
There is an email contact. Do you have that? It's listed in the...
Is it on the Make It Fair website?
Should be on the Make It Fair
Okay, so
website.
go to the Make It Fair website and look for Andrew Filo, and then you can find out more.
Okay.
Let's give him a round of applause.
Thank you.